Now that you've practiced simplifying expressions, let's work on some problems where we're going to apply the order of operations. And usually when we apply the order of operations, we're evaluating. Evaluating means that in an expression, we replace variables, that is, the letters, with numbers, and then we simplify. For example, here's a formula. This is a way of figuring out how much you still owe on a loan. Here's the original amount of the loan, $6,500. And then we're taking away $250 a month, which is what T stands for. T stands for how many months we've been paying on the loan, and A stands for the amount we still owe on the loan. So this formula starts at $6,500 and then takes away $250 for a certain number of months. Now, if we're interested to figure out how much we still owe after we've paid for 2 years, we'd start with the formula and we'd substitute 24 for T. Now, you may think, well, wasn't it 2 years? It was, but we don't use 2 because, remember, T stands for months. And so we have to replace T with 24. 2 years is 24 months. Now we have an expression that we can simplify. We know by the order of operations we're supposed to multiply before we subtract. And then after subtracting, we find that after paying for 2 years, we still owe $500. Now, one of the ways we're going to be evaluating expressions in Chapter 2 is to see whether a number we find going through a procedure actually solves an equation. And that's the idea of a solution, because a number that solves an equation is known as a solution. Equations start with an equality symbol, or a lot of people call it the equal sign. And then we have two expressions. One's on the left and one's on the right. Now our goal is to try to figure out a value for the variable here, for x, so that if we replace both of these with the same number, this side will simplify to the exact same value that this side will simplify to. So in Chapter 2, we're going to be going through a process to try to figure out what that number is that we should replace x with. And that's known as checking your answer to see if it's a solution. Originally, what people had to do, because they didn't have a procedure for solving something like this and figuring out the solution, was they would guess. So maybe they would say, well, let's try a 1. If you think 1 is the solution, then starting on the left, for instance, you would replace x with 1 and simplify following the order of operations, and find that the left side simplifies to -16, and then you go to the right side and substitute 1 for x. You have to make sure you use the same number for both of the variables here. And again, follow the order of operations. You multiply before you add, and you can see that this isn't the same number. That means 1 isn't the solution. On the other hand, say somebody guessed, 21. Well, we'd start with the left, replace x with 21, and then follow the order of operations to find that the left side simplifies to 64. And then we go to the right. Again, we'd replace x with 21. We'd multiply and add. And this time, both the left and the right side are the same number. Now, what the number is isn't important. The point is, it's the same. That implies that we have found the solution. It's 21. Mathematically, the way that we tell people the solution is to build a solution set, a set of all the numbers that are going to make the left side and the right side the same. So this is the solution set for this equation. It's your turn now. Please check whether 2 is a solution for this equation. Starting on the left, I substitute 2 for x. I simplify inside the parentheses. I multiply and then add. The left side simplifies to 4. Over on the right, I substitute and add. Again, I get 4. That tells me 2 is the solution, and so here's my solution set. Let's say that this was our equation. See if 2 is a solution. After substituting and simplifying both the left side and the right side, I see the values are different, so 2 isn't a solution. How about 1? Replacing x with 1 both on the left and the right, and then simplifying, I find both of them are 5, which tells me that 1 is a solution. How about -1? See if that works. Here I've substituted -1 for x. I simplify the left side, I simplify the right side. Again, these don't match, and therefore -1 isn't the solution. So the solution set for this equation would be 1. Here's a few more. Say this is our equation. See if any of these are a solution. Starting with -1 and making sure all my sign issues are correct. Notice how important all the work we've been doing up till now in Chapter 1 is to being able to simplify both the left and the right side. In this case, I get -6 on the left, 6 on the right. -1 isn't a solution. If I try 6 and simplify, again, the values don't match, so 6 isn't a solution either. When I try 11, though, both the left and the right side simplify to -18, so 11 is the solution, and here's the solution set for this equation. And here's the last one. See if -1's a solution for this equation. After substituting and simplifying, on the left I'll need a common denominator, so I write 1 as 2/2. I find that the left simplifies to 1/2. On the right I already have a common denominator, so I can simplify to 2/4, which again reduces to 1/2. Since the values are the same, -1 is a solution, and here's my solution set. I hope this video has shown you the importance of evaluating expressions to figure out if a value is the solution to an equation.